Alright, we're starting a unit, unit 7, and today we're going to do 7-1, multiplication properties of exponents. Our essential question today, how can you determine the product of two powers? Now today and tomorrow's essential question will be the same, but you'll only have a summary section on the bottom of this set of notes. So you're going to write your summary at the bottom of this set of notes. So we're going to start with products of powers, okay? So products of powers, we have our key concepts here, and I want to pull a couple things out of them. Now, if you have, say, 8b squared, this is a term. This is your coefficient. That is the number that's in front of a variable. When we have an exponent, this is considered the base, and this is your exponent. Okay? Now, we're going to deal with our coefficients later. I want to talk about bases and exponents a little more. Okay, so you're only a base if you have an exponent. If you have an exponent, you have a base, okay? And you only have one base per exponent, all right, when it is written like this, okay? So b is the only thing that's squared here, so it's b squared, all right? And what's happening really is 8 is multiplied by b squared. We just don't put in that multiplication symbol because the multiplication is implied. Okay, so in our example, we have b squared times b to the fourth. So b squared is, well, break it down to b times b. And that's multiplied by b to the fourth, all right? Well, b to the fourth is b times b times b times b. So we keep our base, which is b, and well, how many times is b multiplied by itself? We got 1, 2, 3, 4, 5, 6, 6. Well, what do you do to 2 and 4 to get to 6? You add them together. You add them together. So we add our exponents when we're dealing with products of powers, okay? So basically a base with an exponent times another base with an exponent would give me b to the 6th power. Now, your bases aren't always variables, all right? Sometimes your bases are numbers, all right? And when our base is a number, we handle it the same way. We keep our base, we add our exponents, okay? That's what we're doing. So let's, instead of b, I put 5 here. So 5 squared times 5 cubed. Well, 5 squared is 5 times 5, okay? And that's multiplied by 5 cubed, which is 5 times 5 times 5. Well, our base is 5, because that's what's multiplying by itself. And how many times is it multiplying by itself? Well, 5 times. So what you do is you add your exponents, okay? Keep your base, add your exponents. Okay, that is what we are doing. Okay, keep our base, add our exponents. All right, now we have got it where we're only multiplying basically 2 terms times each other. You, in your assignment today, will have some larger problems where you're multiplying like 3 or sometimes 4 different terms times each other. And you're going to follow the exact same process, okay? So what you're going to do is step 1, we are going to multiply all coefficients. And that means all of them. If you have a coefficient, which is the number in front of the base exponent, the bases do not have to match, all right? But you're going to take all of these coefficients, all of them throughout the entire problem, and multiply them. Step 1, okay? Again, your bases With the exponents, they don't have to match. You're just going to pull all of those coefficients from all of your terms and you're going to multiply them, all of them, okay? Step 2, okay, you keep all your bases. Keep your bases. And what order do they go in? Well, which base comes first in your problem. That's how you know which order, okay? If you see x first in your problem, the x comes first. If you see y second, then y needs to be second, okay? Keep them in the same order you see them. You're going to keep your base, okay? And then 3, add exponents of like bases. Okay, so that's what you're doing. Multiply all of those coefficients, all of them, okay, don't miss any of them. Remember, they don't have to have the same base and exponent pair next to them. Just pick them all up throughout the entire problem and multiply them. All right, so we are going to group our coefficients and our variables. So we are going to group our coefficients and our variables, okay? So let's see, 3 times 4, and then n to the 4th times n to the 7th, okay? Because it's multiplication, we can rearrange the problem that we have, okay? So we would take all of our coefficients and group them in here. If there were more coefficients, even if you didn't have the same base, you would group them all in this region. And then you just group your bases, like bases. So 3 times 4 is 12. We keep our base of n, and we add these exponents, 11. Okay? We're going to do that again. Okay, we're going to do that again. So we are going to group our coefficients and our variables. So we have 7 times 2. And then our first variable, we've got x, okay, times x to the 4th. And then we're going to group our next variable of y squared times y to the 3rd. All right? Now, 7 times 2 is 14. Now with this one, okay, keep our base. And the biggest thing that people miss is the fact that this x has an invisible exponent of 1. And a lot of my students are missing that, so don't miss that. Maybe even draw it in, okay? So it's visible, so that you remember to add both of these together. And so that's x to the 5th power, and then y to the 5th power, okay? So remember, multiply all the coefficients, even if they do not have the same base, all right? Then you're going to keep all those bases in the order you see them, and then add those exponents of the like bases together, all right? Now let's turn it over, and let's talk about where do we use some of this, where you see this a lot, particularly in school. And if you go on into any of the science, technology-based industries with scientific notation, okay? Product of powers and scientific notation. This is where you see it a lot, and this is where we cross-curriculum with science. All right, so product of powers and scientific notation. We're going to talk about stars. The fastest recorded star in the Milky Way galaxy is US 708, and that's just the name of the star, which travels, okay, it travels at a rate of 2,700,000 miles per hour. All right, that's its rate it travels. How far does US 708 travel in 1 year? Okay, that's time. Okay, write your answer in scientific notation and round to the nearest 10th. All right, so we're going to round to the nearest 10th at the end. And it tells you 1 year equals 8,760 hours. Now, why does it tell you that? Because we're in our rate, we're talking about miles per hour, all right? So when we talk about time, then you'd be talking about it in the hours of the year. All right, the hours of the year. So when we are mathing like terms, okay? These are both in reference of hour. One's in miles per hour and one is in hours per year, but they're both talking about hours, so they are going to be like terms. Okay, step one. Let's convert the speed of US 708 and the number of hours in the year into scientific notation. All right, so we are going to do the speed, which is our rate, and number of hours in the year, which is our time. Now, scientific notation. Okay, you have a number in front. Okay, with scientific notation, you have a number in front times 10 to an exponent. Okay, your number in front times 10 to an exponent. This is called scientific notation. We do this for a couple reasons. Mainly because it's easier to math. Because trying to math with 2,700,000, if you look at your calculator, you only have so many spaces on a calculator. So this is a way of dealing with really large numbers and really small numbers that you particularly see when you're dealing in the sciences. All right. So let's talk about this number here a little more. Okay. So we're talking about scientific notation here. Scientific notation. Okay, so it looks like this. You have a number times 10 to the y power. All right, it always looks like this. It's always times 10 to a power. All right, let's talk about this box a little more. So this number here, that's going to be in front of the times 10 to a power. Well, it's going to be greater than or equal to 1, but it's going to be less than 10. All right, so here's basically what we're doing. All right, so it has to be a number that is greater than or equal to 1, but less than 10. We want basically one digit in front of our decimal. All right, one digit in front of the decimal is greater than or equal to 1, but less than 10 when you have one digit in front of our decimal. So let's move some decimals, okay? So we know every whole number has a decimal behind it. All right, and we're trying to get to 2.7. Well, how far do we have to move our decimal? That is invisible, but we're making it visible, and we're going to move it to do so. So it's always at the very end of all whole numbers, okay, and let's make it visible, and let's move it to right behind that 2, so we could get 2.7 into this box. All right, so we're going to move it 1, 2, 3 times, 4, 5, 6 times, okay? And we moved it to the left. All right, so that means if you 2,700,000 into scientific notation, okay, we're going to get there. So, and 2.7 is greater than or equal to 1, but less than 10, okay? To get back to 2,700,000, you would have to multiply 2.7 times 1 million. Okay, there's 3 zeros, and now we have 6 zeros. We moved our decimal 6 places, so whatever for a front number in our scientific notation, okay, how many zeros? Well, there's 6, okay, so 2.7 times 1 million would give us 2,700,000. And we moved our decimal to the left. Now, moving your decimal to the left, it's very important to know that. All right, so we need to get onto the scientific notation, so 2.7 times 10 to the what power? Well, how many times did we move that decimal, and how many zeros are in a million? Well, 6. The answer is 6 for both, okay? Because 1 million converted into scientific notation would be 10 to the 6th power. All right, so with scientific notation, when you move the decimal to the left, okay, your exponent is going to be positive. Now, we don't need it for this example, but later in the week, especially when we get to negative exponents, you are going to need to know what happens when we move the decimal to the right. Well, what do you think? If moving it to the left makes it positive, then moving it to the right makes your exponent negative. Okay? And what we're doing is when you have to move your decimal to the left, we are starting with a very large number. So that means you are going to multiply by 10 to whatever power it is. Now, when you move to the right to get the term in the box for the scientific notation, what you're doing is you're starting with a very small number, and you're having to move that decimal place to the right so you get a digit that will, satisfy this box requirements. And that is going to be a negative exponent, which means you will be actually dividing by 10 that many times, okay? And we'll get to that on Friday when we talk about negative exponents more. All right, so we have gotten our speed or our rate into scientific notation. Now let's do our hours in years. All right, so we want to get 8,760 into scientific notation. We're going to make that decimal visible, and we're going to move it 1, 2, 3 times. Okay, and again, we moved it to the left, so that's 8.76 times 1,000, because I have 3 zeros. All right, and remember the number in the box for scientific notation has to be greater than or equal to 1, but less than 10. Okay, so 1 digit in front of that decimal. Now let's convert 1,000. That would be 10 to the, how many powers? Well, 3. And what that is, to get 8.76 back to 8,760, you take 8.76, multiply it by 10 in the calculator, multiply it by 10, multiply it by 10, and you'll get back to your original number. Now, we've done all of this so that we can do a formula that you do a lot in science as you go through your science classes. That's your distance formula. That's rate times time. Okay, distance equals rate times time. That's what this formula means. And we are going to find the approximately how far US 780 travels in 1 year. All right, that is why you need to have your rate and your time referencing the exact same time frame, which is hours. All right, so we are going to fill in what we don't have. So what we are missing is our rate, all right, which is the speed. Okay, the rate is the speed. Okay, and the time, this was hours per year. All right, so in scientific notation, you have 2.7 times 10 to the 6th power for your rate. And they are already filled in scientific notation for hours per year. Okay, then we use the commutative and associative properties. That is what we are doing. Those are the properties in math we are using when we are grouping together our coefficients, all right, and then we are grouping together our bases with exponents, all right. Now let's multiply. 2.7 times 8.76 is 23.652. Okay, now let's do the product of the powers. So that's times 10, because you keep your base, and you add your exponents. So 6 plus 3 is 9. All right, but are we in scientific notation? Okay, are we in scientific notation? Does this first number comply with this rule? Okay, is this number that's in front of the times 10 to a power, is it greater than or equal to 1 but less than 10? No, it's not. And to be in scientific notation, it must comply with this rule. So in order to comply with this rule, we have to move our decimal point one more time. And when we move our decimal point one more time, remember when you move your decimal to the left, it is times 10. Well, how many times did you move that decimal? Once. But we also have this one here, 10 to to the 9th power. Can't forget that, okay? So we are now in scientific notation for our box. Now let's get to where we only have one base and we've added together our exponents, all right? So product of powers, we're going to simplify 2.3652 times 10. 1 plus 9 is 10. And then it said round to the nearest 10th place. And this is our 10th place. And we round based on the hundredths place. And that 6 tells us to round up. So 2.4 times 10 to the 10th power. All right. Your assignment is in Alex. It is labeled 7-1, day 1. It is a few problems. Make sure you show your work on paper. Write down the equation, write down any groupings that you do, adding your exponents, things of that nature. Make sure you show all that work on paper so you can get the grade. And then you also must score above an 80% because we are practicing the skill. Good luck.